Welcome to Train Signal. You're watching a video about securing data. In this video, I'm going to show you a couple different ways to secure data that you have stored on your servers. One way is through NTFS permissions, and the other is through something called the encrypting file system, or what's more commonly known as simply EFS. So first, let's take a look at NTFS permissions. NTFS permissions control the level of access that users have to resources on our server. And an example of resources would be things like the files or data on our server. Now, these NTFS permissions can be set on individual files, or you could set these permissions on folders, and then by default, all the files within a folder would inherit those permissions. Now, likewise, permissions can be assigned to the individual users. So one by one, you can take a user and say you have access to this file and not to this file. Or you can go ahead and assign the permission to groups, and then any user who is a member of that group would then inherit that permission. Now, this next bullet point here that says permissions are cumulative. This is something that you will see when reading any material about NTFS permissions, and it comes off as quite confusing to many people. What this means, permissions are cumulative, is that if you are a user of different groups, and each one of those groups have been assigned a different level of NTFS permissions to the same file or folder, well, when determining the effective permission for that user, you accumulate the different permissions. So as an example over here in the picture, this isn't a picture of what the permissions would look like when you're in the operating system or when you're editing them within the operating system. If by being a member of one group you were granted one level of permission, and by being a member of a different group you were granted a different level of permission, well, by being a member of both of those groups you end up accumulating or having both permissions. Now, we'll take another look at this when we get into the operating system itself. Probably be a little more clear at that point. The other thing I need you to know about NTFS permissions is that deny always overrides allow. And again, this has to do with when determining the effective permission. If you are the member of a group who has been granted the allow permission for an individual file or folder, and by being a member of another group, you've been granted the deny permission, the end result is that you would be denied access to that file or folder because it always takes precedence or overrides the allow checkbox. Matter of fact, you'll see when we're looking at the operating system, anytime you check a deny box, the operating system will throw out an extra warning at you to make sure that you truly understand what you're doing, because that deny will always override any other allows. You could literally be a member of 10 different groups. 9 of the groups grant permission or allow permission to a file, and then that 10th group is denied access to the file, and you end up not having access to the file because the deny always overrides allow. Alright, well, enough talking about it. Let's go ahead and take a look at the specific NTFS permissions, how to assign them, and how we determine effective permissions. Okay, to take a look at NTFS permissions, we can pretty much connect to any Windows Server 2008 computer, because whether it is a domain controller, a member server, a standalone server, it really doesn't matter. All servers are going to have data, and that data is going to have permissions assigned so as to control access to them. So in this case, let's go ahead and connect to New York Member 1. And let me go ahead and double click on that now. And the reason I want to connect to New York Member 1 is because typically your member servers are what will be your file servers, where you'll have the majority of your data that you're making accessible to your users. Alright, so now that I'm on New York Member 1, the first thing I'm going to do is click on Start and select Computer. And this will open us up into Windows Explorer. Now I'm going to double click on the C drive, and you'll see here there's already some folders and files. Well, we don't want to mess with any of that because that's all pretty much there for the operating system's purposes. So to demonstrate this, let's go ahead and create some new data. So I'm going to right click in the open area here and select New Folder. We'll go ahead and name this folder Data. Kind of makes sense. We're going to put some data in there, right? So let's double click on the folder. And in that folder, again, right click. And this time I'm going to select New Text Document just to create an individual file. And we'll just go ahead and call this Data File 1. Okay, so we have now a file. So let's take a look at the permissions on the file. We do that by right clicking and selecting Properties, and then on the Property sheet selecting the Security tab. Now in the Security tab, you'll see here there are already some groups that are listed, and they are the system for the operating system itself, the administrators of this particular computer, and the users group for this particular computer. You'll notice that the administrators have checkboxes for pretty much allowing everything, right? Allow full control, which includes everything else. Whereas users only have been allowed read and execute. Now let's take a quick look at these 5 individual NTFS permissions. The first one I want to start off with is right here where it says read. Read means just that. If you have permission to read the file, you can open the file. Now a lot of people get confused with then what this next one is above it, read and execute. And the only real difference there is if you have read and execute permission, you can not only open data files, but you can also execute or launch application files. Okay, so if you have applications or executables, well then you can execute those files. Now if I go down here to write, it means that you can now write to that file, or you could make changes to that file. Modify would allow you not only to read and write, but also would allow you to delete the file. So you want to be careful with that one if you give someone permission to modify a file. And then full control encompasses everything else and then gives a little bit extra level of access, which includes, as a for instance, the ability to actually assign or modify these permissions on the file. Full control means just what it sounds like. You have absolute full control. There's nothing you can't do with this file. Okay, so those are the standard NTFS permissions for a file. Now before we get into editing those permissions, I want to show you one other thing. So I'm going to go ahead and click cancel to get out of here. I want to back up to where I am just looking at my C drive, and on the data folder itself I'm going to right click and select properties so that I can show you that, again, clicking on the security tab, we still have the same groups, right? System, administrators, users. We also have this other special group called creator owner, and that basically means if somebody were to create something within this folder, regardless of what group or groups they may be a member of, they are the creator and the owner of that individual piece of data that they created. So I just want you to see here that for the standard permissions, we still have full control, we still have modify, we still have read and execute, but now we have an extra one stuck in here between that and read, which is list folder contents. Now it wouldn't make sense to have something called list folder contents permission on a file, and that's why it's not there, because list folder contents means just what it says. It means that you have been given permission to basically see what is inside this folder. So it's possible that you could grant someone permission to see what's inside a folder but not be able to actually launch or read the data, the files themselves, the data in that folder. So there's a lot of flexibility that's been built into these NTFS permissions. And then also, just like with the file NTFS permissions, there are these special permissions which we'll get into in just a little bit here. So let's go ahead and take a look at some of these permissions. Now you'll notice here on the folder that administrators have been granted full control over the data in this folder, so they can pretty much do anything and everything. And individual users can see what's in the folder, they can read what's in the folder, and they can read and execute what's in the folder. Very similar to what we just saw on the file. Okay, so now let's take a look at how to edit these permissions. Basically, you do so by clicking on the Edit button. And we can do so because we are an administrator, and administrators have full control, which allows us to edit the permissions. So I'm going to click on Edit. And now we get a very similar window, except for now, instead of just seeing check marks down here, we actually have check boxes. Now I want you to notice that if I click on Administrators, these check boxes are checked, but they are grayed out. So if I were to try to uncheck them, if I were to click on them, nothing happens. I'm not allowed to. That's what grayed out means. It's been locked in this window. And the reason it's been locked is because these permissions are being what's called inherited from above, from a higher level in the hierarchy. And we'll talk about inheritance in just a moment, but that's why the boxes are grayed out. Whereas these boxes that are not grayed out, I could go ahead and check the boxes at will. So here we have our administrators and we have our users. And again, the users boxes are grayed out because that's been inherited. If I would like all users on this particular folder to have full control, I could add that level, but I can't remove the grayed out boxes. All right, let me get rid of those. And now let's go ahead and add additional users or groups to the list of who has permissions to this particular data folder. And you do so by clicking the Add button. So I click the Add button. If you know who it is you want to add, you can type the name in this box right here. If you don't know, then you can click on the Advanced button and you can put in search criteria. And if you enter no search criteria at all and just click Find Now, boom, look at that. Because I said from the globalmantics.com location, it shows me all users and groups within the entire domain. Now we don't have a whole lot of users and groups in this particular domain. We haven't added any. So for right now, let's go ahead and use some of the default ones. So as a for instance, we'll just go ahead and take like our domain users. I'm going to double click on it. You'll notice domain users gets entered into the box and click OK. And domain users has now been added to this box. This box, by the way, this list, if you want to call it that, is a very appropriate name because it's technically referred to as an access control list, or in Windows, more specifically, it's referred to as a discretionary access control list, or DACL. Now don't worry about DACL, or what's sometimes referred to as DACL for right now. Just know that it's a list of users and groups that have been allowed or denied access to this particular resource. Now, by default, you'll notice that the domain users, or any group that you add, is going to have read, list, read, and execute permissions. But let's go ahead and say we want to give our domain users a little bit more access. So let's go ahead and give them modify. Matter of fact, you know what? Let me go ahead and clear that checkbox. Let's clear all the checkboxes. Let me scroll down. Okay, let's clear that box. All right. The reason I want to clear the boxes is because I want you to see what happens when I check the modify box. I'm going to check it again. And there you see that all the other boxes do get checked again. And the reason why is, as I mentioned before, modify encompasses the read, list, read and execute, and write permissions, as well as giving them the ability to delete the data as well. Okay, so now our domain users have been granted modify permission, which is a little bit more than what we were giving our local users, right? Our local users still only have, actually they have read, list, read, and then also they've been granted write. How about that? All right, so let's go ahead and add another group. I'm going to click on Add, and this time in the box, I'm going to type the word domain, and then click Check Names. What the system is going to do is it's going to look for all users and groups that include the word domain. So here I see we have our domain admins, domain computers, domain controllers, domain guests, and domain users. All include domain. So let's do our domain guests. Click OK. There they are. Click OK. See them on the list here. And in the case of our domain guests, we don't want them to have access to this particular data. So I'm going to, in the deny column, click deny full control, which again is going to check all the boxes because full control includes everything. So users who are a member of the domain guests group, they're not going to get access to this data. Now I'm going to go ahead and click apply because I want you to see what's going to happen here. When I click the button, you'll see here that you get that extra warning that I was talking about before, saying, hey, do you realize that you've checked a deny box? Deny overrides everything. You may not get results you were looking for, basically because if a user ends up being a member of this group, as well as other groups, regardless of the permissions you thought you were giving them, deny is going to always override. So are we sure we want to do this? And I'm going to say yes, I'm sure we want to do this. And now we've assigned permissions for the data folder. Now, a couple other things I want to show you here. One, down here we have our special permissions. Let's take a look at this. I'm going to go ahead and click OK to close this window. The way we look at our special permissions is by clicking on this Advanced button. When you click on the Advanced button, you get a much more advanced interface as to what level of permissions a user has or doesn't have to a file or folder. When I click Edit here, matter of fact, let's, domain guest is fine. I'm going to click on Edit. And then you'll see here that actually, just like before, it's kind of interesting in Server 2008. You have to do everything twice. I'm going to go ahead and click on Edit again. You will see here that I have a much more detailed list of permissions which go into much more detail than the standard permissions. And a couple of the specific permissions that you really need to know about are these two at the bottom. There's one here that's called Change Permissions. That is something that would be included only with full control standard permission, but is something that you could give individually. Maybe you want somebody to have the ability only to read access to a file, but you want to give that person, let's say in an emergency, the ability to go ahead and change permission and give themselves permission. Now that might sound just really goofy, but it does actually happen out there. And the reason has to do with something called auditing. When you're auditing things that happen on your network, it's easier to notice when somebody has changed permissions than it is just to notice that they simply accessed a file. So sometimes you won't give someone access to a file, but you'll make it that they can change permissions to give themselves access, and then that would stand out. You would then be alerted, let's say, to realize, wait a minute, this person now accessed the file. There must have been an emergency. I want to know why. But anyway, change permissions, that's what it means. It means you're granting or denying somebody the ability to change permissions on a file or folder. Another special permission here is something called take ownership. Every file and folder has an owner. You may recall the creator owner group that we just saw a moment ago. The owner is originally would be the creator of that file or that folder. But that ownership can change if somebody has been given the permission to take ownership. If they've been given permission to take ownership, let me go ahead and cancel out of this window and cancel out of this window. You'll see here that there's an owner tab. The owner tab will show who the owner is. If you've been granted permission to take ownership, then you would be able to click on this edit button and go ahead and take ownership and make yourself the owner of the file or folder. Now, why would you want to do that? Well, you may want to become the owner because by default, owners have a built-in full control permission to a file or folder, and that permission can't be taken away as long as they are the owner. Now, you want to be careful with who has ownership of a file because ownership will sometimes show you who's doing certain things on your network. You may want to know, wait a minute, where did this file come from? I don't like the fact that this file is here. It's got information that I don't like, or maybe information that's confidential and shouldn't be open to the public here. Who's responsible for this file? Sometimes you can tell by the owner. So those are some of your special permissions as far as, let me go back into the screen here, that you can take a look at. The rest of these permissions are just much more detailed versions of the existing standard permissions. But again, you may want to get down to that level of detail in some scenarios, but it's not very, very common. All right, let's go ahead and cancel out of there. And something else that I want you to take a look at is, let me go ahead and cancel all the way out. Let's go into the data folder and let's look at the properties of data file 1, security tab. You'll notice that data file 1 now has the domain users and domain guests on its list, and domain users have been given modify permission. Domain guests have been given the deny full control permission. And that is because by default, files inherit permissions from their folders. Matter of fact, we can go a step further and we can say that folders by default inherit permissions from the folder that they are in. It happens all the way down through the hierarchy. So as a for instance, let me cancel out of here. If I were to set permissions all the way up here at the drive level on our C drive, all files and folders by default within that C drive all the way down through the hierarchy will take on those permissions or inherit those permissions. And let me show you why. Let's go back into our data folder. Right click, Properties, Security tab. If I go back to the Advanced window, click on that button. Here you will see that there's a checkbox to, by default, include inheritable permissions from the parent. Now let me click on Edit because it's a little bit easier to see. Here, include inheritable permissions from this object's parent. Alright, if we don't want to inherit permissions from above, if we don't want to get our permissions from any folders that I reside within or folders that those folders reside within, I simply clear the checkbox. And when I clear that checkbox, it's going to ask me, well, alright, if you're not going to inherit permissions anymore, what do you want to do with the permissions that you already inherited? You can either copy them and make them your own. So what that's saying is the permissions you already inherited, keep them. But don't inherit any more permissions. Or you could select to remove them. Now I'm going to select remove in this case because I want to show you exactly what happens. I'm going to click remove. You'll notice that my list gets quite small. And the reason why is because the only permissions that I assigned to this folder specifically were the domain users and domain guest permissions. All the other permissions that we saw previously were all inherited. So let me go ahead and check that box again and click apply, and you'll see that all of those other permissions come back. Now the other checkbox that's here says replace all existing inheritable permissions on all descendants with inheritable permissions from this object. This kind of goes back to the old days of Windows NT, where you used to assign a permission on a folder and then you manually would decide if you wanted to force those permissions to inherit downward. So they've kind of put that back in case you want to go back and do that, where you want to force things downward. But that's typically not done because by default the down level files and folders are inheriting unless you've explicitly said I don't want to inherit, at which point you probably don't want to force it on them. So this is the significant checkbox to really make note of. Okay, now what I want to do is let me go ahead and cancel out of here and cancel all the way out. Let's go back and let's take a look at some examples of what happens when you have users who are the member of multiple groups and what their effective permissions become. Alright, so in this first scenario that I want to take a look at, let me go ahead and read it to you. It says there are a couple of groups in your domain called the accounting users and accounting managers. And you'll see here that I have pictures illustrating the accounting managers and the accounting users groups. The accounting users group has been assigned the allow read permission to the accounting folder. The accounting managers group has been assigned the allow write permission to the accounting folder. Now John, you'll notice that I have John here who is a member of both groups. What is John's effective permission? In other words, user John is a member of accounting users, is also a member of accounting managers. Accounting users has been given read permission. Accounting managers has been given write permission. What does John end up with? John ends up with an effective permission of allowing read and write because it's cumulative. He received the read permission by being a member of accounting users. He received the write permission by being a member of the accounting managers. Alright, let's look at another scenario. Now, John is a member of a group called the accounting users. Permissions have been assigned to the accounting folder as follows. John individually has been allowed read and allowed write permission. The accounting users group has been allowed read and denied write. What is John's effective permission? Well, let's see. John individually has been allowed read and allowed write. The accounting users are also allowed read, so it looks like John's going to be allowed read, but has been denied write, and this deny always overrides allow. So John's effective permission is that he will be allowed to read and explicitly denied the ability to write. And let me actually make a clarification on a word I just used there. I said that he was explicitly denied write. And the reason I said explicitly is because there was a checkbox. See, there is what's called an implicit denial or an explicit denial to resources on a network. If a user has not been given access, so if you have a user and you haven't listed that user or any groups that that user is a member of in the permission list for a file or folder, well, then it's implied, since we haven't granted access, that that user has been denied access. And sure enough, the user will not have access to that file or folder. But in the event that that user were to become a member of a group, let's say, that was given access to the folder, well, now the user would get access. So that's what we mean by implied denied. Whereas explicit denial is where you have a user who is a member of a group, or maybe that user themselves have actually been, they actually have this deny checkbox checked, so they've explicitly been denied a certain permission. And that means no matter what group that user's a member of, they will be denied permission. All right, let's look at one more scenario. In this scenario, now we're going to get fancy with it. There are 3 groups in your domain: the accounts payable, accounts receivable, and accounting managers groups. The accounts payable and accounts receivable groups have been assigned the allow full control permission to their respective folders. So I have that listed for you right here, where you can see the green lines will show you what the current permissions are. The accounts payable group has full control to the payables folder, and the accounts receivable group has full control to the receivables folder. The accounting managers group has been assigned the allow read permission to the accounting folder, which is up here. John is a member of the accounting managers and account payable groups. Right? We have that here. Again, John is a member of managers and accounts payable. You need to give John full control to the spreadsheet 1 file, which you'll see is down here in the payables folder, while making sure that the rest of the accounting managers group is denied access to this file. All right, so let's take a look at where our current permissions stand so we can figure out what, if any, changes we need to make. We said that the accounting managers have allow read to the accounting folder, right? We have that here. But what that means is, because permissions are inherited down through the hierarchy, the accounting managers are also going to have read to the receivables and the payables folder, which also then would include this spreadsheet file. Here we have the account receivable group having full control to the receivables folder. We have the payable group with full control to the payables folder, which again, through inheritance, means that they have full control to the spreadsheet folder. And what does this mean for John? It says, well, currently John has full control of spreadsheet 1. Why? Because John is a member of accounting managers, which gave him read, and accounts payable, which gives him full control, which means the end result is full control over spreadsheet 1. But the accounting managers group will have read access as well, right? And we said that we want the accounting managers to be denied access to this spreadsheet file. So how are we going to take access away from the accounting managers group without changing John's level of control? Now, if we were to set the deny permission to the account managers group, right? I don't know if you were thinking that, but if you were thinking that we would now take the account managers group and deny them access to the spreadsheet 1 folder, the problem is that by putting that explicit denial, John, being a member of that group, would lose access as well. So that won't work. What we need to do is we need to stop inheritance on the spreadsheet 1 file and then give John exclusive full control permissions. Okay, so what we're saying here is that you take the spreadsheet 1 file, you clear the inheritance and you remove any previously inherited permissions. And then on that one particular file, explicitly give John, the user, permissions to that file. Another choice, depending on your scenario, is maybe we explicitly give accounts payable permissions to the Spreadsheet 1 file. The scenario really didn't say. It said that you wanted to give it to John, so we give it to him explicitly. Okay, so now that we've seen a few scenarios on how we would figure out effective permissions, let's actually add some users to our network and grant them permissions and see what the results are. Alright, in order to add users to make them available for this example, we need to connect to one of our domain controllers. So I'm going to go ahead and connect to New York DC1. Now, once we're connected to New York DC1, we're going to have to go into Active Directory. And I'm going to need for you to just basically follow along if you are indeed trying to do all of these labs. But you would need to go ahead and take a look at an Active Directory course in order to get a full understanding of exactly what we're doing. So what I'm going to do is I'm going to go ahead and click on Start, select Administrative Tools, and then select Active Directory Users and Computers. This will take us into the utility within the GlobalMantics domain. Here you can see globalmantics.com, where we can go ahead and add some users. So I'm going to go down here to the Users container, and I'm going to right-click on that container. When I right-click, I'm going to select New User. And let's just go ahead and I'm going to go ahead and create the user with the first name Ed, last name Lieberman. That makes sense. That's me. Give myself a user logon name of E. Lieberman, a typical logon name, first initial, last name. And then we're going to go ahead and assign a secure password. You can go ahead and put in whatever secure password you like. And I'm going to uncheck the box that says that I must change my password at next logon. We're going to go ahead and leave that password. Matter of fact, I'm going to say that that password never expires. Now again, don't worry about these details if you don't understand exactly why we're doing this. It's fairly self-explanatory to where basically what I've just done is I've created a user, given a password, and said just leave that password alone. Don't ever make me have to change it. That way, as we're going through some of these examples, we won't ever be prompted to change passwords needlessly. So I'm going to go ahead and click on Next and Finish, and you'll see we now have user Ed Lieberman. All right, let's create another user. Right-click, New User, John Doe. Username J Doe. Next, give it a password. It's the exact same process as before. Clear that box, never expires. Next, finish. Alright, so now we have a couple of users in our network. How about we create a group to work with on our network? I'm going to right click. Even though we're in the users container, that's okay. I'm going to right click and select New Group. And we're going to leave these alone as a global security group. And we're just going to go ahead and give this group a name. And we're going to call this group Data Users. And then we're going to go ahead and create another group. Right click, New Group. And we're going to call this group Bad People. Alright, so you can see here, and they've kind of highlighted them in gray to show you the new stuff that we've just added. We've got a couple of users, Ed Lieberman, John Doe, and a couple of groups we've created called Data Users and Bad People. Okay, so now what I'm going to do is I'm going to go to the Data Users group, and I'm just going to go ahead and right click. Oh, let me highlight just the one group. Right click and select Properties, and go to Members, and we're going to add, and I'm going to put in Ed, check names, and you'll see it goes to Ed Lieberman. Click OK. I'm going to add, and I'm going to put in John, check names, defaults to John Doe. I just added those two users to the Data Users group. Alright, now you'll also notice if I go to the properties of Ed Lieberman and go to the Member Of tab, you'll see that I am a member of not only the Data Users, but by default I was a member of the domain users group as well. Alright, let's go ahead and I'm going to minimize out of our domain controller, and I'm going to go back to our member server, back here where we have our data folder. Now I'm going to go to the properties of the data. Matter of fact, I'm going to go into the data folder and go to the properties of the data file within the folder. Let me go to those properties and click on security, and you'll notice the list has not changed. We still have our administrators, users, our domain users, and domain guests. I'm going to click on advanced because I want to show you that right here there's this effective permissions tab. When I click on the effective permissions tab, this gives me the opportunity to quickly see what a user's effective permission is without having to necessarily go through the whole list and figure out what groups they're a member of, etc., etc. So I'm going to click select, and I'm going to put in Ed, check names, goes to Ed Lieberman, and click OK. And you will see here that I can traverse the folder, list the folder, read, create, write. These are all the, by default, not by default, but it always will show you all the detailed special permissions that go beyond just the standards. But as you can see, basically everything is checked here other than full control, which of course is what is needed for the change permission or take ownership permissions. But everything else is selected. Now, although this is a quick and easy way of determining what my effective permission is, we don't know why that is. So let's go ahead and cancel out of here, and let's see if we can't figure it out. Well, if we go from the bottom, is Ed Lieberman a member of the local users? No. Local administrators? No. Domain guests? No. Ed Lieberman is a member of the domain users group, and the domain users group has been given modify, read and execute, read and write. In other words, domain users have the ability to do everything except for the specific full control permissions. That's how the Ed Lieberman user got those permissions. So let's change this now. Let me go in here and edit these permissions, and let's take the domain users out. Let's remove domain users. Oh, look at that. It says that I can't do it because it's inheriting permissions from the parent. See? So that's an example where we may want to stop inheritance, or more specifically, let's just cancel out of this and let's go back up to the folder level, and we'll do it there. Security. All right, and there we're going to take our domain users, and we're going to go ahead, oh, I'm sorry, I have to click on edit first. Domain users, and remove the domain users, and now we want to add, and I'm going to type in the word data because we have our data users, right? Check names, data users, okay. And the data users, they only have read and execute, list and read, right? That's all that's been selected for that particular group by default. Click OK. And now let's go back to the Advanced button and the Effective Permissions tab. So let's select, let's put in Ed Lieberman once again. And you'll see here now, Ed Lieberman does not have everything but full control. Now, I only have the ability to read. I can create files, I can list, I can read, but I can't write, I can't delete. Okay, I can't do any of the stuff that I was given through the modify permission that I had previously. So you can see how that changes. But now, let's go ahead and let me cancel out of here, edit. Let's add the, I'll type in the word bad. Let's add the bad people group. And the bad people group, we're going to go ahead and say because they're bad people, they've been denied access to anything. Very similar to the domain guests. Matter of fact, let's get domain guests out of there. That wouldn't be very common to use. We're going to use bad people. They've been denied access. And I'm going to click OK. And advanced, effective permission, select, put in Ed. Hey, look at that. I still have permission. Why is that? Oh, because I'm not a member of bad people. So let's go ahead and let's back out of here. I'm going to minimize our member server for just a minute. Let's go back to the domain controller and let's go to bad people and look at the members. There's nobody there. And let's add, now I don't want to add Ed Lieberman. I don't think I'm a bad person. You might think I'm a bad person, but I think I'm okay. So let's put in John. And we're going to say that John Doe is a member of the bad people group. Matter of fact, if we take a look at the properties of John Doe and go to the Member Of tab, you'll see that John Doe is a member of the domain users, the data users, and bad people. All right, so a member of 3 groups there. Let's go ahead and go back to our member server. And now you'll see here that there's 2 groups that John Doe is a member of, the data users group and the bad people group. Let's click on Advanced, Effective Permissions, select, and put in John Doe. And you'll see here that John Doe's effective permission, look at these checkboxes. They're all empty. John Doe has no access at all. But wait a minute, that doesn't make any sense, right? Because John Doe is a member of the data users group, which has access. It's because John is a member of the bad people group, which has been denied access. Okay, so that's an example of an explicit denial. How about we take a look at the implicit denial? Let's go ahead and get the data users out of here, and let's even get the local users out of there. Oh, again, I can't because it's being inherited. So what I need to do is cancel all the way out, go to the C drive properties, security, and we can go ahead and remove it at this level. Now you want to be real careful about this. That's not a real good idea what I'm doing. So it's something that we're going to want to go back and probably put back in. But for right now, I'm going to go ahead and click OK. And you'll notice it says, you know, you're about to do something on your startup disk, which could give you bad results. But okay, I know what I'm doing right now, so I'm going to say, yeah, I want to do that. And now it's giving me an error. How about that? All right. Just click through a bunch of errors because it's basically saying, wait a minute, this is a bad thing that you're doing. But don't worry about that because I just want to illustrate the point to you here. We'll go back and fix it later. All right, going back to the data folder, properties, security. Let's go ahead and get rid of the data users. And you'll see all that's left is creator owner, system, bad people, and administrators. Ed Lieberman user is not a member of any of those groups. So if we go to advanced, and again go to effective permission, select, put in Ed Lieberman account, you'll see here that Ed Lieberman no longer has access to anything. All right, now before we forget to do anything else, and I'm going to do this with you in case you are following along, let's go back to the properties of our C drive and go ahead and add, and not from this location. This is what you want to change, not from the globalmantics.com location, but from the local machine. We want to do the users group. Okay, that's what we had before. And you'll see that the default is that they can read, listen, read. It's what we want. Click apply. Yes, I know I'm about to make these bad changes, and it's going to say I'm denied a whole bunch of times. Sorry, clicked through the screen one too many times. It says that I'm denied, but I'm not really denied because I am an administrator. It's just getting mad as a protection of, there's certain aspects of things that it's not going to take away those permissions, or else basically the operating system could just completely die on you. So you want to be careful with this. But now we've put it back in, and everything is back where it should be. Alright, so that is pretty much how NTFS permissions work. Now let's go back and talk a little bit about the encrypting file system, or EFS. Okay, now one thing to kind of talk about right out the gates when it comes to the encrypting file system, or EFS, is why do we even need it? I mean, when looking at NTFS permissions, isn't that good enough? I mean, wasn't that already pretty thorough at securing our data? Well, yeah, it is. I mean, NTFS permissions provide very good protection within the Windows operating system. But the problem is that an attacker could, if they got physical access to a hard drive, put it into a non-Windows environment, so another computer with a non-Windows operating system. Well, NTFS permissions would be gone. because the NTFS permissions are all managed by the Windows operating system. So using EFS would add an extra layer of protection because it encrypts the data right on the disk. Files that have been encrypted using EFS are therefore unreadable to other operating environments. Now, EFS was first supported back with Windows 2000. They made some slight changes in Windows XP and has been pretty much the same ever since, other than the interface might have gotten a little bit friendlier. Matter of fact, the interface is so friendly and it's so simple that most of what we're going to talk about here is going to be the concept of how EFS works and what's going on behind the scenes. Because I think it's important that if you're going to do this, you know how it's working. Now, in order to understand this EFS concept, you have to understand the concept of something called cryptography. And cryptography is the concept of applying an algorithm, or a formula we could say, to plain text, right? Text that we can read normally, and then convert it into something called ciphertext, or what might be the encoded data. So an example I have here is if we had an algorithm that said go up 2 letters. And this is kind of fun. This is something kids do in school all the time. Is you can take the words train signal and turn them into or in other words, an unreadable set of words. And what we mean by go up 2 letters is we take the T in train signal and we go up 2 letters. So T, and then go up 2 letters, U, and then V. And so that's why we have a V over here. And then the letter R goes up to ST. Right? We get a T over here. A, B, C. That's why we have a C over here, etc., etc. And that's how we encrypt the data. Right? We have our plain text over here and our ciphertext over here. And again, just like the kids do in school, when you send this secret message over to your friend has to know what the algorithm is so that they can reverse it. And in this case, it would be to go down 2 letters to take this and turn it back into readable words. Now, most of the algorithms that are used today are publicly known. There are only a few set algorithms that we use to go ahead and encrypt data. The way we keep the algorithms secure is by using something called a key. We're using a common algorithm that is publicly known. Well, if I send a message, well, somebody else can go ahead and reverse the algorithm and get back to plain text. So this key is a variable within the algorithm. And you might have heard of a saying, like, if you ever hear anybody talking about using 128-bit encryption, what they're referring to is the use of a 128-bit key, which would be a very large key. And without that key, you don't truly know the full algorithm. So here again, I have an example to where the algorithm that is publicly known is to go up X letters, right? Everybody knows there's a standard algorithm. Let's go up X letters. The key is X. Okay, so what that means is the letter X is being used as a variable. So if X equals 2, then just like we saw before, train signal becomes this set of letters right here. But if X was 5, so if the key changes, if that variable becomes a 5, well, then train signal becomes a separate set of letters. Because in this case, now T needs to go up 5 letters, so we have U, V, W, X, Y. And that's where we get the Y from. R becomes S, T, U, V, W. And that's where this W comes from. And then we go ahead and continue that out. So the only way to now turn this ciphertext back into readable text would be to not only know that the algorithm is that we're going up a certain number of letters, but we have to know how many. And again, using something like this where the key is X, and X can be, pretty much anything from 0 to, I guess, 26, because there's only 26 letters in the alphabet. Well, it wouldn't be that hard to crack the code, because you could go ahead and try every single possible scenario until you come up with readable words. Now, EFS uses two different types of encryption. One type is called symmetric key encryption, and that's where the same key is used to encrypt as is used to decrypt the data. And so what that basically means is I will have the key and I will use that key to encrypt the data, and then that exact same identical key will be used on the other side by whoever I'm sending that data to, as for instance, if we were sending data. Now with EFS, you're not necessarily sending it, and we'll come back to that in a minute. But let's say for the sake of argument we're sending the data. The recipient would then have to use the same key to reverse the algorithm. There's another type of encryption that's used with EFS called asymmetric encryption, or what's more commonly known as public key encryption. Public key encryption is a little more complicated. It uses something called key pairing, where there's a pair of keys that go together at all times, and one key is used to encrypt the data, and then the matching paired key, or so it's a different key, is used to decrypt the data from cipher back to plain text. So in that instance, if I were encrypting the data, I would use one key, and then if I sent that data to somebody, the recipient would have to use the matching paired key to decrypt the data. Now I know that this public key encryption can be confusing, so let's make sure we fully understand that aspect of it. This is all going to be hypothetical just to understand how this works. So kind of clear your mind of everything else. Let's say that every user on a network has a pair of keys. One key in the pair is accessible only to the individual user, and that key is called the private key. Why is it called private? Because it's available only to the individual user privately. The other key in the pair is publicly accessible. Everybody has access to it, and you'll never guess what that key is called. That's right, it's called the public key. Okay, so for right now, real simple, everybody has a pair of keys. Private one that only they have access to, and a public one that everyone has access to. So in an example where we have 100 users on our network, there'd be a total of 200 keys. 100 keys would be private and would, as a for instance, let's say is sitting in the pocket of each individual user. So it's private. It's only available to that individual user. And then there's 100 other keys that would be publicly available to everybody. We'll say just sitting in a box that everyone has access to. Each user would therefore have access to a total of 101 keys. The 100 public keys that everyone has access to, plus their one private key. Now, any key can be used to encrypt data. It does not matter. There's 200 keys. Any of them can be used to encrypt data. That's the easy part. But once the data has been encrypted, only the matching paired key can be used to decrypt the data. So once it's been done, of the 200 keys, there's only one key that can undo it or decrypt the data. Okay, so let's take a look at an example of how public key encryption works. Let's say John wants to send secure data to Mary. Well, here you'll see we have a picture of John and Mary, and John has a private and a public key, and Mary has a private and a public key. Well, what John needs to do is take the data and encrypt it with Mary's public key. Now he can do this because even though it's Mary's key, it's Mary's public key, which is available to the public, to everybody. Now the data has been secured, it is encrypted, and he will send this data over to Mary. Now, as we said before, because the data was encrypted with Mary's public key, there's only one key that can decrypt the data, and that is Mary's private key. So Mary is going to decrypt the data with her own private key, which can she do that? Sure, because she has access to that private key. Matter of fact, she is the only one that has access to that private key. Now, let's say somebody else was to have intercepted this data. Let's say while this data was being sent across from John to Mary, let's say that somebody else grabbed it, okay, and took it somewhere else. Could they access it? Well, it was encrypted with Mary's public key, which means the only key that can decrypt it is Mary's private key. Now we know Mary can do it, right? She has access to her own private key. Does anybody else have access to that private key? No. So therefore, this is truly a secure transmission because the only person, once it's been encrypted with their public key, that can access the data is the person who has the matching private key, which will be that one individual. Now that doesn't tend to be too difficult for most people. Most people get the idea of, okay, you go grab somebody's public key to encrypt the data and make it that only that person can access it. But what about if John wanted to send authenticated data to Mary? So now we're not so much worried about securing it, but we want Mary to be able to validate who it really came from. Well, in this case, John will now encrypt the data using his own private key. Right? John has access to his own private key, encrypts the data. Takes that encrypted data, sends it over to Mary. Now, although I just referred to it as encrypted data, we're going to talk about whether it's really encrypted or not. Because Mary is now, the only way she's going to be able to open that data is by decrypting it with the matching paired key. Now, if it was John's private key, which encrypted, what would be the matching paired key? John's public key. Mary does have access to John's public key, so she can do that. Now, in this same scenario, if we were to take that data and say that somebody else intercepted it, could that somebody else have read the data? Yes, they could have. Why? Because John's public key is what was used to decrypt the data, and everybody has access to John's public key. So that's why we're saying this is not used to necessarily encrypt or secure the data. This version is used to verify the authenticity of the data, because when somebody opens the data, because they had to use John's public key, they know that John's private key had to be originally used, and only John has access to John's private key, so John had to have been the originator of the data. This is sometimes referred to as digitally signing the data. It's almost like putting a digital signature by encrypting it with your own private key. Okay, so that's kind of how public key encryption works. And as a matter of fact, I will tell you that's why the name is public key encryption, not private key encryption. Because when you do true encryption, you're taking somebody's public key to encrypt the data. When you encrypt using a private key, that's not really encryption, that's authentication. Okay, now that you know the basics of what cryptography is, how it works, we know that there's this thing called symmetric key encryption. We know there's this thing called public key encryption. Symmetric key encryption, use the same key. Public key encryption, we use paired keys. How the heck does this all relate to EFS? Well, as I said before, EFS uses both symmetric and public key encryption. And here's how it works. The first step is that the file is encrypted using a symmetric key. So if I have a piece of data and I'm going to secure it using EFS, what the operating system is going to do is it's going to use a symmetric key to encrypt the data. This key is very often referred to as a FEC, a file encryption key. Next, that key is then copied. And it is copied, there's one for the actual user who originated the file, and then a copy is made for what's called the recovery agent. On every network, you should have a recovery agent. That is one user account on the network who will have access to all of the EFS encrypted data. And the way they have access to all the EFS encrypted data is by this step right here, where we make multiple copies of this symmetric file encryption key. One for the user, one for the recovery agent, and then also anything Windows XP or newer, you can also make one available, make a copy of this key available to additional users who you want to grant access to this file. I will talk about that in more detail when we get to the actual interface. Alright, so now that we have our multiple copies of the FEC, the last thing we do is that each copy of the FEC is then individually encrypted using the respective public key of the user who needs to access the file. So the user's public key will be used to encrypt the file encryption key. Let's say the second copy of the file encryption key will then be encrypted using the public key of the recovery agent. And let's say there was one additional user, so there would be a third copy of the file encryption key, which is then encrypted using the public key of that separate user. Alright, I don't know about you, but that was pretty confusing. So how about I see if I can't illustrate this, make a little more sense. Alright, John has a file which needs to be secured so that only he can access it. Plus, although we just said he only can access it, he also wants Mary to have access to the file. Here's how it works. In order to make this all happen, we have our actual data file, right? We have to have a FEC, a file encryption key. We have John's public key, Mary's public key, and then the recovery agent's public key. All right, those are all the components we're going to need. Here's how it works. We're going to take the file and put it into a box. Now again, this is just to try to illustrate it. There's no literal box that the file is going into. So just think of it as the file is being put into a box. The file encryption key is then used to lock that box. All right, so we now have data in a locked box. The file encryption key is then copied, and in this case there's going to be 3 copies, which are going to be put in 3 smaller boxes, which we're going to attach to the original box. These extra smaller boxes are going to be what's sometimes referred to as header information to the data, and I'll give you more detail on that in just a moment. But we have the 3 separate copies put in 3 separate little boxes. We take John's public key and encrypt the first box, so we've locked it with John's public key. We take the next box and we lock it with Mary's public key. And we take the third little box and we lock it with the recovery agent's public key. We now have a completely secured EFS piece of data. Now the one other thing I'll add to this is, remember I said I'll go into the header information? These header fields, these first 2, are what's known as the data decryption field, or DDF header information. That the data decryption field is where you will find the FECs that have been stored for the individual users, and then this last header field, the DRF, is what is used for the recovery agent's copy of the key. And it's called DRF, by the way, is the data recovery field. Okay, so now that we have our EFS encrypted data, how does somebody access the data? Well, if somebody were to approach this data, what would they see? They would see 4 locked boxes. And if you walk up and you see 4 locked boxes, what are you going to do? You're going to check to see if you have a key that can open any of those locks. Well, John, Mary, and the recovery agent each have a key that would work. And here's how. If John wanted to access this data, his private key could be used to access this particular field right here. Why? Because it was encrypted using John's public key. And of course, the matching key is the only key that can access that field. So John would take his private key, unlock that box, take out the file encryption key, unlock the big box with the data in it, and boom, take out the data. If Mary were to have approached this particular set of locked boxes, she would have taken her private key to this field, and the recovery agent would have taken their private key to that field. But the rest of the process would work the same. If anybody else approached these 4 locked boxes, well, they would check their pockets and they'd find that they don't have any keys to unlock any of the boxes. So that is how EFS is securing the data behind the scenes. Let's go ahead and see how you actually would be accessing EFS through the operating system. Okay, so back here on our New York Member 1 server, you see here that we have our data folder. Now the first thing I want to do is I'm going to go into the data folder and take this data file 1 that we previously created. I'm going to open it up just to show you that I can open it and say that this is unencrypted. Okay, just to show you this file is unencrypted. Now let's go back out to the folder, right click, go to Properties. On the General tab you'll see there's an Advanced button. Click that button and there's a checkbox for Encrypt Contents to Secure Data. Check that box, click OK, and just that simple, we've enabled EFS encryption. Told you the interface was very simple, just a checkbox. But there is a question it's asking. Do we want to apply changes to this folder only, or to this folder and everything inside of it? Well, I'm going to say to this folder only. I'm going to click OK, and you'll notice that the data folder is now in green. And the reason it's in green is because of a feature in Windows Explorer. Actually, I'll just show you the feature. If I go up to the Tools menu, Folder Options, View tab, and scroll down, you'll see here there's an option, box is checked, to show encrypted or compressed NTFS files in color. So since we have asked for that, all encrypted data will show up in green to let us recognize quickly that that is the case. So I'm going to go into the data folder, and you'll notice that data file 1 is still in black, meaning it's not encrypted. But if I were to create a new file, right click, New, Text Document, we'll call this one data file 2, you'll notice it's in green. Matter of fact, we'll go inside of it and say this is encrypted. Help if I could spell, right? Okay, let's close that, save it. This file has now been encrypted using EFS. There's a file encryption key that was used to encrypt the data, and then the public key of the user who's currently logged in, which is administrator, has been used to encrypt that file encryption key. Alright, now I'm the only user that can get to this data, and I need to prove this by logging in as another user. But to take this a step further, let's go back into the NTFS permissions. Let's go to the Security tab. And let's get rid of, well, let's go into Edit and get rid of bad people. And let's add, and we're going to add domain users. We're going to add the domain users and say that domain users have been given full control access to this folder. Okay, so domain users, of which the Ed Lieberman account and the John Doe account that we previously created are members of, now have full control access to this folder. Now you'll see in a moment why we want to do that. What I'm going to do is go ahead and log off as the administrator. Matter of fact, I'll just do it as switch user to make it a little bit easier to go back and forth. And now let's log in as another user. Let's log in as the E. Lieberman account. Logged in as the E. Lieberman account, what should happen is I have full control to the folder, right? Let's take a look. Start, computer. Here's the data folder. And if I try to open up data file 1, no problem. This is unencrypted. But if I try to open up data file 2, which I should still have full control permissions to, access is denied. Okay, and you'll notice I no longer see the text that says this is encrypted because it's encrypted. I can't see it. Okay, so that kind of shows that the Ed Lieberman account has been, matter of fact, all accounts have been denied access other than the original administrator account who encrypted the data. Matter of fact, if I go to the properties of this particular file and go to security, you'll notice that sure enough, domain users have full control, so I should have access. Alright, now, just to show you that this is not administrator based, I'm going to go ahead and create another new text document. But this time, I'm logged in as Ed Lieberman, and I'm going to create data file 3. And again, it's in green, but this time it's encrypted so that only the Ed Lieberman account can get to it. I'm going to open up that file and say this is for Ed only. And go ahead and close it, save it. If I open it, I can get to it. Great. Let's go ahead and log off, or actually I'll switch user again. And let's go ahead and log back in as the administrator. And you'll see here if the administrator tries to go into the data folder, the administrator can see data file 3, but even the administrator, the all-powerful administrator, is denied access. Okay, so that shows that it's not just the administrator account. Now, let's say that the administrator account wanted to give access to the Ed Lieberman account to this data file 2, right? I can still open that up. This is encrypted. Well, let me back up one step and show you how you cannot do it. Okay, if I were to go to the properties of the data folder, and you're going to see why I'm showing you this in a minute, because this is what you're going to want to be able to do. I'm going to go to Advanced. You'll notice there's a Details button right here. It's grayed out. And the reason why is because it's this button that you use to give other users access to the EFS encrypted information. You cannot do this to an entire folder. You can only do this file by file. So let's go ahead and go back into the data folder and go to the individual file, Properties, Advanced, and now you'll notice I can click on the Details button. So I click on the Details button, and I want to add a user who is going to be able to access this file. And here is the E. Lieberman account. So I click OK, and click OK, and OK once again, and OK one more time. What I've basically just done is I've just asked the operating system to go down to the local hardware store, take the file encryption key, and have a copy made. And now that copy is put into another little box, which has now been encrypted using E. Lieberman's public key. Okay, so what I'm going to do is go ahead and log off, or switch user, and log back in as E. Lieberman, and attempt to access. Well, first of all, here's data file 3. I can still get to it, right? But here's data file 2. Boom, I have access to it now. But if anyone else were to try to log in, they would not have access. So that is how EFS works. All right, well, let's go ahead and get out of here and go back and review what we've covered in this video. Okay, after watching this video, you should now know how to assign NTFS permissions to individual files and folders. You should be able to figure out what a user's effective permission is based upon the different groups that that user may be a member of, either through the effective permission tab, which shows it to you, or through going through and figuring out one by one what groups a user is a member of and accumulating the permissions and see what the end result is. And you should also now know how to secure data using EFS, the encrypting file system. All right, that's it for this video. I'll see you in the next one.